I want to talk about how we can solve some bigger exponential equations using logarithms. Remember, logarithms are simply the inverse operation, the inverse function of exponentials. And I made an earlier video that talked about the relationship that a raised to the x power, so this exponential equation, a raised to the x equals b, could be rewritten as log base a, so notice the base of my logarithm is the same as the base of my exponential, of my answer b is equal to x. And again, remember, inverses say, I know what the answer is and I want to find the input. So that's exactly what this is saying is, how do I find the input, the x? Okay? Now, on our calculator, because most calculators don't have a way to type in bases, we actually typically type this in as log of b divided by log of a. And this is called a change of base formula because we're dividing both, if we don't write a log, it's considered base 10. This changes it to base a. So that's how we'll actually type this in. So let's do a problem. Now, like a lot of things in algebra, we always want to boil down to kind of the simplest solve for x piece, and we want to move everything else first. So you see in this case, I have 3 to the x plus 4 equals 93. I would like to have an exponential in this form where it's simply the exponential equation. So in this case, just my 3 to the x is equal to a number. So the first thing I'm going to do is I'm going to subtract 4 from both sides. So I've got 3 to the x equals 89. Now it looks like this form right here. I could rewrite this using logs. Log base 3 of 89 equals x. And then, like I said above, the way we would actually type this into our calculator is the log of 89 divided by the log of 3. So the log of 89 divided by the log of 3. 4.086, however much you want to write. I'm going to round to the hundredths, so I'm going to write 4.09. So our x is 4.09 if we round to the hundredths place. Okay, let's do another problem. So here I've got 2 times 4.2 to the x plus 9 equals 53. And again, I want to isolate the exponential equation. I want to leave this part till the end. Now, I should just mention, because a lot of times people see parentheses and they think distribute. You can't multiply something that is not exponential into something that is. So we can't distribute a 2 into this. So we're going to kind of solve around. We're going to do minus 9, which leaves us with 2 times 4.2 to the x equals 44. We're going to divide both sides by 2. So we have 4.2 to the x power equals 22. And again, we're to our exponential form like this. So I can rewrite this as log base 4.2 of 22 equals x, which we would type into our calculator, log of 22 divided by log of 4.2, which I just typed in as 2.15. You might want to verify that on your own calculator. Let's do one more. Okay, I added a little wrinkle here, and you'll see that I've just made the exponential an equation rather than just an x. This isn't going to change much of our process till the end. I'm still going to solve around this exponential. Leave that alone to begin with. So we're going to begin by adding 7. Then we're going to divide by 3. And that doesn't reduce, and it's not a real, it's a repeating decimal, but I'm just going to leave it as 35 thirds. So I've got 2 to the x plus 3 equals 35 thirds. Well, we're to this form now. We have our exponential isolated. So I'm going to rewrite this as log base 2 of 35 thirds is equal to x plus 3. Well, of course, this part on the left can be rewritten as log 35 thirds divided by log 2. Let me type that in quick. So we've got log 35 divided by 3, log 35 thirds divided by log 2. So 3.54. So now, let me just show you that last step. We've got 3.54. Let me move everything up if I can, just a little bit. I've got 3.54 right here equals x plus 3. And of course, I'm solving for x, so I would just subtract 3 at the end. So if there's a little bit of an equation in your exponent, that adds that one step at the end. That's not a huge deal. But just be aware, once you rewrite and you use your log, log base 2 of 35 thirds is equal to this whole thing. So just keep that until you have this side, calculated, and then you can simplify. Now, I do want to point out that there are some log rules that you learn often in pre-calculus that deal with exponents, where you say, if I have something like an exponential, create myself a little more room for myself here. Something like this, you say 2 to the x equals 50, and you say, I'm going to take the log of both sides, like that. Of course, it's an algebraic thing. You do something to one side, you do it to the other. There's a log rule that states that when you take the log of an exponential, the exponent drops to be a multiplier like this. So you end up with x times the log of 2 equals the log of 50. So you then can divide both sides by log of 2 in order to get x by itself. Just notice that's exactly the same thing we would have up there. So for Algebra 2 students, I think this is really what you should kind of be thinking about, this transform. But in pre-calc, you'll learn some other ways to think about doing this that maybe could make it a little bit simpler. If this video helped you, please like and subscribe for more math help.